Ladies and gentlemen of Precalculus, good morning. We're going to solve some exponential and logarithmic equations today, and so I hope we're going to put together some of the things that we've done in the past, recently, and we'll kind of see how they work. And so you're looking at, we're going to go one at a time, and I'll see how many we get called up here to help out in the situation. We'll see how this goes. When you look at this, trying to solve this equation, what do you expect would be a technique for this? Anyone?
Solve for x.
Well, yeah, solve for x. What would be a technique to solve for x? Okay, well, one thing we could do is we could actually change this into a logarithmic equation,
Oh, I said that.
right? But there's probably, for a lot of these, an easier way to do it, and I'm going to try the easier way to do it first and show you how it works out for a lot of these. This one here, first step, what do you think? Divide by 36? Does that make sense? So we have this 1/3 to the power of x over 5 equals 1/9. Now, one thing we could do is we could take log base 1 over 3 of 1 over 9 equals x over 5, right? That's one way we could do it. Or what if we made these bases the same? Here's a base over here. How can we make this 1/9 a base of 1/3? Can we rewrite 1/9 with a base of 1/3? Yeah, how can we do that? So what we'll do is we'll take
1 over 3 squared?
1 over 3 squared, right? Yeah, 1 over 3 squared, exactly. So we're going to have 3, and that's going to be 1 over 3 squared, so we're going to do this, right? So now we have the same base. Was that your idea, Justin? That was a really good idea, Justin. So now, do we have an equation we can set up to solve for x? We have the same base, and we have these exponents. What do we know about these exponents?
X over 5 equals 2.
Yeah, so we know that x over 5 should equal 2, right? And so now we cross multiply, x is equal to what?
2x.
Cross
You say
multiply.
cross multiply?
5
10.
times 2 is 10.
Why would you not do 2x?
What is your question?
Why would it not be 2x plus 5? If you're cross multiplying.
You're multiplying the 5 to get the x by itself.
So this, what is, you multiply this over
I
here.
guess that makes sense.
And what this is, what this is really, and Chloe and anybody else, what you're really doing here is you're multiplying the whole equation by 5. You see that? And when you do that, you get, on the left side, you get 5x over 5, and on the right side, you get 5 times 2. And so that's what cross multiplying does for you, okay? Okay, questions on that one? And yes, we could do this. We could have taken log base 1/3 of 1/9 equals x over 5. And so we could have 5 log base 1/3 of 1/9. That would get us our answer too, right? Are you checking your answer out there? Checking it out. It says check your answer also. And really, so if you plug in 10, so 10 divided by 5 is 2. And 1/3 squared is 1/9. And 36 divided by 9 is 4. All right? Now I think problem 2 is very similar to problem 1. Is it? Yeah, so go ahead and try to work out problem 2, and then depending on reading the room, I might spin the wheel, choose somebody that way. Yeah, this works. Take attendance. All right, should I spin the wheel on this guy?
Yeah. And Roberto.
Spin the wheel. Yeah, so Roberto can have his chance. He's-
It's like 5% Roberto's just gonna be.
Okay, so it's just going like this, so I'll just go. Robert, 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 Robert. No, it's Chloe. Didn't work. It worked during second period. I got who it. Okay, Chloe, did you finish this one?
Yeah, I think. So.
All right, go ahead. I like that.
So you would divide by 32, both sides.
Okay.
You would get 1/4 to the power of x over 3 equals 1 over 1, equals 1/16.
Okay.
And then you do 1/4 to the power of x over 3 equals 1/4 squared.
Okay.
And then you would make it like a little arrow, and you would do x over 3 equals 2.
Equals 2. Okay. Exponent the same place. So x is equal to
X equals 6.
x equals 6. Okay. Any questions on that? Pretty simple. Good job. Good job. Yeah, good work. One of these here. So you're doing this in addition to the stack of stuff you already have.
Yeah, I only have like 3 pages left.
Well, really? That's. Are you watching videos of them or that? Okay. Because there should be videos in 2 places. There should be a video of the QR code on the paper itself, and then there's the class that actually went over it too, which actually does more of them than the class. Okay, good work, man. This is going to be good. Okay, this one right here. Ready for this one? Spin, spin, spin.
Now it's Roberto.
So here,
It's gonna be you, Roberto.
as well, Karina gets picked a lot too, so yeah. It's gonna
I
be
told
hard.
you it was gonna be you.
Yeah, I was cheering for Robert last time, but here he's got this one.
You're welcome, Robert. least you don't have to go.
It's a small, you know you're gonna get picked, so it's a small class anyway, right? What do you got, Robert?
Divide by 2 on both sides.
So we're left with this equals 125,
Yeah.
right?
And you divide by 5 too?
This is a base. At this stage, what I would do is I'd either do a logarithmic one, or I would try to make this a base of 5 somehow. Can you rewrite 125 as an exponent with a base of 5? Think about it a minute. Think about it, Robert. We have people nodding their heads, so the people who can help you on this, if you don't figure it out.
It is a 5.
It's a no.
5 to the third power?
5 to the third power, want to try that? We'll try it. So you get 5 to the x equals 5 to the third power. Is that right?
Yes.
Yeah.
5 times 5 times 5, okay, so what do we have now?
X equals 3. Oh, no. X equals 12.
Thank you, Robert.
Oh. Sorry.
All right, thank you, Robert.
Didn't realize you were a boy, Nicole.
My bad, dude.
Nicholas.
Nicholas, yeah. Nicholas, we got Nicholas right
If
here.
everybody had a boy name, and like the boys had girls' names,
Yeah, what would yours be? You had a horse name.
Connor.
no,
Chloe's Connor, shut up.
no. Not Connor. It'd be Carson.
No.
Some things are hard, like Elizabeth, to have a boy's name for Elizabeth, that somehow doesn't work, does it? Very well.
Elizabeth, Eli.
Oh, Eli, yeah, Eli, that's right.
I
was
do
about
this
to
all
say
day.
Alexander.
Yeah, okay.
You look like an Alexander. Nicole is Brian.
Literally Nicholas.
Okay,
This
let
is
me
the
pick
name.
somebody else.
You're literally Brian.
Yeah, let me pick somebody else here.
That's a nasty name.
Okay,
Nasty name?
here we go. Oh, yes, Riley.
Yeah, Riley.
All right, Riley, what do we got here?
So divide both sides by 3. And got 4 power of x over 2 equals 32.
Okay.
And then, which step comes up
You look for a common base between them. Now, this isn't going to be as easy as 1 through 3, obviously, because you can't rewrite this as a base of 4, right? But what can you do? Is there a
Common
common base?
denominator.
Is there a common base to both of those numbers, 4 and 32? There is, it is.
Would it be?
64.
No, it's
64.
32. It should be, isn't 4 squared?
No, that's 16.
Oh, 4.
64.
Here,
4 to the
6 squared.
4 to the third.
go lower, go lower.
Oh.
2 squared.
Go to 2, yes.
Oh.
What do we have here?
2.
So 4
2 to the power of 4.
is 2 squared, right?
What?
And this one here is going to be
4 squared. That one's
2 to the power of,
3. 4.
4. Why couldn't
5.
you just do 4 squared? Because 4 times 4 is 16, 16.
Because that's not 32.
yeah, it'd be 16 or 64. This would work if this was 64.
Yeah, that's what I was saying. I wanted to do 4 to the third.
So now,
Common denominator.
we can multiply, right, 2 times that. So now we have,
Riley, you got a complicated one.
yeah, so now we have 2 to the power of, we have 2 times x over 2 equals 2 to the power of 5. And so x is going to be equal to
7.
X is equal to 5.
Stupid. I
At
didn't know
this
it either.
point, we should just go over it.
I didn't know it either. It took me a while.
Does that make sense, Riley? Is this going to work out? Yes. Oh, yes. Let me see, if we try 4 to the power of 5 halves times 3. So 4 to the power of 5 halves times 3. Well, that's going to be square root of 4 is 2 to the 5th power is 32 times 3 is 96. Check. Okay? Next we have, I don't know, Riley. Oh yeah, this one here. Yeah, Riley, why don't you do this one? Because I know you can get this one, right? We're gonna hold Riley accountable.
Say you're on.
I got to 10 to the power of negative x over 3 equals 10.
Okay, good. Well, we'll get that far. So you divide it by 2,
Yes.
right? So you got 10 to the power of negative x over 3 equals 10, right?
Mhm.
So this is 10 to what power? What number power is 10 to the power of?
1.
10 to the power of 1. Right? So what equation can we do to solve for x now?
Negative x over 3 equals 1.
So negative x over 3 equals 1. So x equals, so x is equal to negative 3. Okay, now another thing you can do is that's going to be your answer. Another thing you do is this. You can divide by 2. So you have 10 to the power of negative x over 3 equals 10. And then you can take a logarithm here. So log base 10 of 10 equals negative x over 3. So here you have 1. That is 1, right? So 1 equals negative x over 3. It ends up being the same thing.
Well, I got number 6 right, so.
Did you? Okay, well, we can go to that one. We can go to that
And
one.
you've done 3.
She's awesome. She'll get like 2 people. Same type of problem. So she's, okay, this is what I like. This is what I like. All right.
You
So,
gotta spin, Mr. G.
okay, I'll give you credit, Riley, anyway. There we go. I will spin.
So Elizabeth,
Becky.
Close.
Becky's a usual suspect.
it's gonna be Nicole.
Okay, Becky, what'd you get for this one?
So divide 3 by both sides.
So what do we get for this one?
So negative x over 4 equals 12. X equals negative.
Yeah, so we get negative x equals 4, so we multiply by negative 1, we get x is equal to negative 4, okay? So that's going to be that one. And let's turn to 7. And I'm kind of skipping on the checking to get through more stuff this time. So this is one, recently we've done problems like this, haven't we?
Yes.
Yeah, so I think we've done a problem like this twice. Do you need me to do this one? Somebody can do this one, right? Right, you who are remaining to be names drawn, can I spin the wheel on this?
Yeah.
Yeah,
Yes, it's gonna be Nicole.
yeah, probably so. Not really, it's gonna be
And you
Justin.
didn't want to spend the
Oh, man.
Yeah, Justin, you're one of the proponents here, Justin. So what'd you get for this one, Justin?
It's you.
You walked in right when it picked you.
No, it's Justin here.
I passed you.
I'm not really sure where to start.
Okay,
So it's log base 10. X equals 4.
okay.
I'm not really sure what to do here.
Okay, your base, so your base of your logarithm becomes the base of your exponent, right? So here you go like this, goes like this. This comes over here, this goes over here. And then you have the base. This 4 comes over here, and the x goes over here.
Oh, okay, okay.
So x is equal to 10,000,
Gotcha.
right?
Yeah.
Okay. All right. Let's go see Justin if you can. Yeah, Justin, you can do this one.
Okay.
Then give the answer.
10,000.
Which is 10 to the 4th, 10 to the 4th.
Oh yeah, it's easy, just give me a second.
Sure. I can predict what Justin's going to say.
Is X equals 32?
32. How did I know that? Am I a mind reader? No. I'm a mathematician who, like Justin, remembers some of the rules of exponents. And that is that if we have the base of this logarithm will be the base of, so it's saying 2 to the power of what equals 5. That's an exponent. So 2 to the power of what equals 5? Well, it's going to be 2 to the power of 5 equals 32. So that's 32. Is that how you got it, Justin? Yeah, okay, good job. Let's look at 9 and 10. This one here. I'll spin the wheel here in half a minute or less. Okay. Usually this thing would have picked Karina by now, but oh well. It's just the way the thing goes. Elizabeth. All right.
So, you want us to subtract or add 5?
Add 5, like this.
Now use log base 4, x equals 4.
Can we actually do this?
No.
No, we can't do this. Because that's an argument of the logarithm here. So it's not like, if it's minus 5 on the outside, we could definitely do that. We can't do this because of the wrapping up in parentheses of this.
Would you multiply the other side by x minus 5?
No, we can't do that either because it's not like this times this.
Divide by x minus 5.
Okay, what is the base of this logarithm here?
4.
So it's the same thing. We take this, we take this, and so we got 4 to the power of -1 equals x minus 5. And then 4 to the -1 power, that's going to be 1/4 equals x minus 5. Add 5. X is equal to
5 plus 1/4.
5. You can write as a mixed number, 5 and 1/4, right?
Yeah.
But usually I don't like to do it. Usually you're going to put like 5.25, right? 5.25 or 21 over 4? Yeah, 21 over 4. That's what you said. All right, good. Okay, so that's how you do it. Does that make sense, Elizabeth? Let's go ahead and see what 10 grabs for us. You can do this one, Elizabeth, right? All right.
So you put 4 to the power of 1 equals 1 minus x.
Okay.
4 to the power of 1 is 4, so it's 4 equals 1 minus x. And then you subtract 1 from both sides. That would give you 3 equals negative x, and then you multiply the entire column by -1.
Okay. Which gives us x equals,
X equals
okay, -3. And then really, as far as plugging back in, if we substitute in -3, we get 1 minus -3, so that's 4. Log 4 of 4, what power do you raise 4 to get, raise 4 to get 4? 1. Answer.
I already did it. Like 10 minutes ago. Okay, let's start.
All right, thank you, Elizabeth. Let's look at 11. Okay. Now here, is one where it says solve algebraically. So is this a different looking one here?
Yeah.
Kind of? Yeah, it is kind of. And, but it's still a logarithmic one. And I don't think, have I talked to you about the change of base formula? I don't think I have I? Well, I will show it to you. So, same procedure here. So we have log base 1.06 of 4.1 is equal to x. And using the change of base formula, you can use any base you want, and you can say this can be equal to log base 10 of 4.1 over log base 10 of 1.06 equals x. You can do it that way. But there's also there's also a calculator key for this, isn't there? Well, I'll do the change. This is called the change of base formula. This is helpful if you like in your calculator, if you only have an ln key or log key. So what you're going to have is log 4.1 divided by log 1.06. So that'll be log.
Teachers, this is the last call. If you have not gotten your lunch, head down to the life skills and get your lunch. Thanks. Bye.
So we get this decimal approximation 24.215. Let me see what this was here. It was log base 1.06 of 4.1. Man, that doesn't seem right. So. Okay, maybe it is. Log base of 1.06 of 4.1. Please be the same thing, please be the same thing, please be the same thing. Oh, it is. Oh, man. Whew. So, was it 24.215? Okay, does that make sense okay? That is? Okay, good. Okay, next one here, I'm going to choose one of our remaining victims, who are Nicole and Karina.
Oh my God.
So it's Nicole.
Which one are we doing? Negative .043.
Okay, which should be log. That's what you got?
I got log 0.98 over log 1.6 equals x.
Oh, 1.6.
No, so see here it should be. Okay.
Oh, okay.
Yeah, should be reciprocal of that. or something like that.
What did I know?
Should be positive.
I don't know, G.
Change of base
I
formula.
typed it in right, but it's not giving me what it is.
Can I do it?
Yeah, go for it.
So you get log 1.6.
Yeah.
Is it 1.0, 1.6, right?
1.6.
Over log 0.98, right?
Yep. So what I got,
Negative 23 point,
Oh, well, I got that
264.
too.
Did you?
Yeah.
You didn't think it was right?
No, you said it's supposed to be positive.
I think what happened there is I think my intuition failed me, which happens often, more often than I'd like it to. Okay, good work. Let's go to number 13. And we know who that's going to do that one. Karina's going to do that one. All right. Karina, did you do this one? Okay, so just help me out with it. What'd you do first? This? Is that right? So you get e to the 0.035x equals 4. Is that where you got first? Yeah, we're not going to get to every one of these today. We'll probably get up to number 14 or 15, which will be that's pretty good though, that's pretty good.
We only have 2 minutes.
What is the base of this logarithm, Karina? E, right? So log base E of 4 equals 0.035. So x, excuse me, right? X. So this is equal to ln 4, right? Equals 0.035x. So over here we divide by 0.035. We have x is equal to ln 4 over 0.035. So, a calculator. We have ln 4 divided by 0.035. Is that what you got for it? 39.608, does that look familiar?
what was the new 10 minutes? Yeah.
Is that what you got, Karina, on that? You haven't finished? Here's what I want you to do, Karina. Yes, what you got? Okay, good. Okay, Karina, I want you to do this one. We'll probably leave it here today with this one. And while Karina's doing this, I'm going to hand out the little paper towels. So that's pretty, to get through 14 on this today, that's pretty good. Well, I'll get mine. Sure. names on the paper don't contribute to the delinquency of your teacher.
I got it on.
Are we giving it to you?
Yeah, you give it to me. I know you're not gonna be finished with it. You got 14 done? Okay, she's just about done here.
Robert, I did never.
And what I wanna do is, what'd you get as your answer for this, Karina?
24.41.
So you get x equals 24,
Yeah, 24.41.
point
41.
413. So if you divide by 80, you'll get e to the 0.245x equals 3.
That actually should be .414.
0.414?
Yeah, she said 414.
Or did she? Okay. So we'll just leave it there. So are we spraying down the desks here?
Yeah.
All right, thank you.